Okay. Welcome, everyone. Welcome to the webinar today on optimizing Dash app performance with our Dash version 2.9.2. My name is Sushen Dang, and I also have a couple of colleagues who've joined me in this webinar who are going to be helping me kind of organize the webinar from the back end. The agenda for today's webinar is essentially going to be us talking about Plotly and understanding what Dash is, understanding what the Dash architecture is, because it's important to understand what areas we can improve within Dash, within a Dash architecture, to make our Dash applications much more faster. And that's when partial property updates would kick in with our patch class, as well as our duplicate callback outputs. We're going to see live coding in action. I have a bunch of different applications that are going to show you different kinds of performance variations. And then finally, we're going to have some time at the end of the call to ask questions. So, a little bit about myself. My name is Shane Dang, like I said, and I have about 6 years of experience in the BI sector. I've been working with different kinds of tools such as Tableau and Power BI, and I have also been coding in Python. I recently joined Plotly, and even though I wasn't directly associated with Plotly, the idea of joining Plotly and being able to, spread or connect non-technical people with technical people in general, and the whole idea that Plotly allows you to develop end-to-end, production applications using Dash and just using Python was just amazing. And the idea that I would be able to make a difference made me join Plotly, and I have been very blessed to be here. For questions, remember that you'll see a small question mark on your screen in the webinar screen. Feel free to type in your questions into that box, and I will make sure I'll try my best to answer those questions at the end of the webinar. So yeah, please feel free to ask questions within that box. Okay, Plotly at a glance. Plotly has three main offerings. We have the open source graphing library, the plotly.js, which most of you probably know about, and it has hundreds of graphs built in to the Plotly graphing library that allow you to build a graph basically with as less as 4 or 5 lines of code. We also have Dash Open Source, which is an architecture, it is a Python based package that allows you to take these different graphs, build interactions on top of them using callbacks, and then deploy those applications to build full end to end production level applications. And then we have Dash Enterprise, right, which is our enterprise application that allows you to deploy these applications securely, add security with very less amount of steps that are required, design with different packages that you have, get access to support and professional services, and more. So, what is a Dash app? A Dash app can be a full scale analytics application, it can be a simulation system, it can be a financial model, a forecasting system, even a bank management system where you're essentially interacting with accounts, adding or transferring money or different kinds of things that you can code within Python, and you can build these secure end-to-end applications using Dash open source or Dash enterprise. I have also attached a link to our example applications on this deck, which will be available to you uh, at the end of the webinar. Understanding the Dash architecture. I think it's very important for us to understand the Dash architecture and what can be improved within the existing architecture that's going to help optimize our applications to its maximum potential. From a very high level, we have three main things within our Dash architecture. We have our data, we have our Python callbacks, and we have the browser where we're going to be viewing the Dash application. Now, within this, right, when we within this architecture, what can actually be improved? Now, when we write a certain callback, we have the ability to pass certain parameters over the network that go fetch information from our data, which could be a file system, a CSV database, a warehouse API. It could be anything, and then bring that data back over the network. Now, these payloads, right? So we can control two things over here. One, the way we write our callbacks, and two, the amount of data that we're sending over the network. These are the two main things that we're going to be focusing on this webinar. So, what does that mean? For example, the graph that you see on your screen right now, if you want to essentially update just a single point on this graph, which means that if you're changing a single value on this graph, and this plotly figure is, let's say, 200 megabytes in size, you're essentially sending 200 megabytes of data from the browser using the callback to your data server and receiving a 200 megabytes size of response to that. What that means is that for bigger applications, for complex applications, even for smaller applications in general, your performance can gradually become slower because you're dealing with a large amount of data. So how do we make it better? Now that's where partial property updates come into the picture. What we've done with this new update is that we've given you two new things. One, we've given you duplicate callback outputs that allow you an improved way of callback management. So which means that and I'm going to talk about it in a second, but it allows you to improve the way you write your callbacks. And we have the patch class that allows you to control the kind of data or limit, not limit, I mean, to control the kind of data or only send the kind of data that you want to update rather than having to send the entire plotly figure over the network. Let's talk about duplicate callback outputs. Like I said before, duplicate callback outputs. Now, initially, when you had one single output and you had multiple inputs, and when I say inputs, I mean different types of radio buttons. It could be a drop down, it could be a multi-select option, it could be, any normal button in general. When you have multiple interactions with one single graph, you had to write that entire output in one single callback. We've now given you the ability with dash 2.9.2 to actually write or reuse the same output in multiple callbacks. What that means is that, and what that means is, like, initially, if you look at the figure on the left, when you had to write a callback for one single plotly figure, or you had to write all the interactions under one single output, under one single callback. Now we give you the ability to actually write multiple callbacks with the same output with different kinds of interactions. Let's understand the structure and then we'll jump into code. But then the structure is all that is changed is that in your first callback where you're writing your output, all you have to do is you have to add a new argument called allow duplicate equals to true. What this would allow, or what this would tell the dash architecture, is that it will allow the system, or it will allow you to use the same output in a different callback with different interactions, and allow you to manage your code better. Let's see it in action. And I'm quickly going to jump into my dash enterprise instance where I have a bunch of applications that I have prepared for this webinar. But the first one that we're going to be looking at is our duplicate callback outputs. And the reason I'm doing it in Dash Enterprise is just because I have easier access to it, and it's just easier to manage my code and my interactions and my data in here. Now, before I show you the code, what I'm going to do is I'm actually going to just show you what the application is. Give me 1 second. Just going to show you what the application is, and I'm going to run the application here. Just a one click deploy. Just need to make sure that I have my app running, and there we go. Okay, so I have a very simple application here. I have two interactions. One is a draw graph interaction, and one is a reset graph interaction. So when I click on my draw graph interaction, it does nothing but simply just plot the values from that graph on the screen on this graph. And when I click on my reset graph, it resets those values. Let's jump into the code. What I'm doing right now, and the traditional way of doing this was that I had to write all of my inputs, right? Here's my layout. I have two buttons. I have my HTML dot button that is allowing me to draw the graph, and I have my HTML dot button that is allowing me to reset the graph. And here's my graph that I'm creating with the ID graph. Now, initially, or the traditional way to do this was that I had to write both the inputs, which means for the reset button, as well as for the draw button under one single callback. And then based on that callback, the function that I'm defining underneath it could get potentially extremely complex as you start increasing the number of inputs that interact with that data. Now what I've done here is that, and that was one way to do it. I'm simply going to comment this out right now. And what I'm going to do next is I have another thing that shows us duplicate callbacks. So the same thing, the same interactions, but notice now I have callback number one. This is my callback number one. And this right here is my callback number two. Notice the outputs. So in my callback number one, I have output, which has my graph, my figure, and notice that I have a new argument here that says allow duplicate is equal to true. And in my second callback, I have the same input. So when I highlight this, you can see that my output is graph, figure, and allow duplicate is equal to true. And then my reset button input is written in the second callback, and I've defined my reset button under the second callback. And I've defined my draw button under the first callback. Now, what this has allowed me to do is this has allowed me to write the same code, but in a much more organized fashion. And as you can see, I can come here, I can draw my graph, I can reset my graph, same function, same data, just better organization. And that's what you know duplicate callback outputs can do for you. Moving into patch, I think this is going to be super fun to talk about. Patch allows you to update only what is necessary in a component property of the output. Now, some possible changes around this include assigning a new value, uh, you know, merging a dictionary, and appending an item to a list. What does that mean? Let's understand the structure. The code that you see on this particular slide, I'm going to break that code into smaller structures so that I can explain what that really means. What that means is that now we have the ability, so we are creating an object, a patch object specifically. So we have patched figure is equal to patch. Now patched figure is the patch object. The name is arbitrary. You can have whatever name you want, but we're doing patch figure just because it's easier to kind of relate. So we're first creating a patch object. Now this step, the second step right here that says patched figure, layout, title, font, color is equal to new color. Now notice, first of all, notice this is a list, kind of a list format. And then what we're doing here is very important. What we're doing here is that we're assigning a value specifically to the title of this particular value. So we're assigning a color to the title, to the a font color to the title, and only passing that using the patched figure object, using the patch object. So let me explain that a little better. And we're going to jump into code so that I can show you exactly what that means. But what does it mean? What are some benefits? Here's an example screenshot from one of the outputs that we were talking about. And we were able to successfully reduce our payload size by 99.98%. which is amazing. But then it really depends on the kind of code you have, the kind of complexity you have, the kind of data that you have. It depends on a bunch of different things that would affect the kind of performance improvement that you would see. Let's jump back into code. I think it's important to understand and see, what a Dash application or what Patch can do for you. So I'm going to go back to my enterprise application, and I have two more demos for you. So one is an open source, and one is an enterprise application, just because it was easier for me to show more data and more compute. But let's look at the open source example first, and just give it a second to load. Okay, so I'm gonna run this application first just to kind of show you what the application is. And there we go. I'm gonna open this application. Okay, now within this application, you will see that we have a drop down. We have a drop down right here. We have a graph on the left, and we have a graph on the right. Now the graph on the left is how you would traditionally write a callback and how you would traditionally update values when, let's say, for example, a country is selected from this particular dropdown. And the graph on the right, the callback is written using the patch function. And we're going to see exactly, we're going to do benchmarking and understand exactly the kind of difference in performance we have in both of these graphs. Okay. The first thing we're going to do is I'm going to select a value, and keep your eye out on both the graphs before I select a value, and we'll try to see if we can see any visual difference. So let's say I select Argentina. Now, when I select Argentina, it's a very slight difference because the data that we have here is very small, and it's not that big of data. But then I'm going to select another country right here, and we're going to try and see if there was any slight difference in speed. Well, there was, but then how do we see it? How do we see what each callback was doing? There's two ways. One, I have this debug option inside my Dash application that tells me exactly how fast the interaction was. And I can even change the way I'm seeing that. So it means that the value, which is our dropdown, when I select that, the patch option, which is number two, took 192 milliseconds to update our graph, which is our figure. Whereas the traditional option, which was the first one, it took 1035 milliseconds to update our graph. That in itself, right there, is an improvement of close to what, 80% in performance. Let's look at that in action. I'm going to go into my developer tools. I'm going to be in my network filter. What I'm going to do here is I'm going to come in over here, and I'm going to select another country. So let's say I want to select Bahrain. Now within this, and I'm going to make this a little bit more bigger if it's hard to see, could get hard to see. So here are our two callbacks. So the first callback right here, which you see, it shows that it sent 136 kilobytes, or the network payload was only 136 kilobytes of data, and it took 194 milliseconds to execute. Whereas the second callback, or the first callback, the one that wasn't using patch, had a payload of 544 kilobytes, and it took 1.05 seconds. Again, close to an 80% performance improvement by just using patch. Let's jump into the code and understand what we did here that helped us achieve this 80%. It is insane. Okay, so traditionally, the way you would do this is we have our output, we have our input, and within this, when we're defining our function to update the values, we're saying that for every country that was selected, send the color red. Otherwise, let the value for that country be blue. And what we're also doing is we're updating the marker size, so which means the size, as you can see in this graph, the red. So here, every red button over here, right? So it says Bahrain. So we're updating the marker size so it's visible on the screen. And we're saying for every other country, let it remain at 6. And then finally, this is where the difference lies. Finally, what we would normally do is we would say that, update traces because it's a scatter plot. We're going to say that the marker color is going to be, whatever the marker color we have over here, the marker size, and then we're returning the entire figure over the network. So even though we're updating the value just for Bahrain, we're sending, even if let's say this has 200 countries in it, we're sending the data for the entire 200 countries over the network. Now in patch, what we've done is everything till update marker color and update marker size is the same. Now, instead of actually simply just passing that value or passing the entire figure over the network, what we're doing is that we've created a new patch object, and we've stored it, or we've created a new variable called patch figure, which is essentially a patch object. And what we're saying is that in here, for the data of the figure, for for the marker, set the color to red for the selected country. And we're saying set the size to 24 or whatever, or to 24, correct? And then all we're doing is that we're simply just returning the value that needs to be updated rather than having to send the entire value over the network, which causes the network payload to reduce, essentially increasing the size, essentially increasing the efficiency of your Dash application. Let's look at another example. And this example, I preloaded this example just because we're dealing with an 80 megabyte GeoJSON data. And I've been talking to a lot of scientists, I've been talking to a lot of engineers and a lot of customers, and I've seen that a lot of different organizations, they use choropleth map boxes. And so I was like, I think it's high time that I show users an idea of how much of a difference can this make. The graph, and this is my demo, the graph or the choropleth map on the left, what we're simply doing is we have a slider here, and what the slider is allowing me to do is just control the opacity of different countries within this map. The slider on the left is programmed using our patch function or our patch class, and the slider on the right is using the traditional method of updating the opacity within a graph. And now, and if you were not able to see the visual difference in the previous open source application demo, you're now going to see it. Now I'm going to update the value for my left graph, and then let's say I want to set my opacity to 0.5. Let's see how much time it takes. Boom, done, we're good to go. Not that big of a deal. And we're dealing with 80 megabytes of GeoJSON data, by the way. Now, on the right is what we have for the traditional graphs, and I'm going to set the opacity to 0.5. Same data, again, remember, before I make this change, it's the same data, it's the same graph, it's the same values. The only difference is that I have used patch on the graph on the left, and I have not used patch on the graph on the right. As you could see, it took quite a bit of time to update the graph on the right. Let's see what the performance was in our callbacks. 50 milliseconds is what it took for our patch function, and it took 11,529 milliseconds. That is almost, and I would say 99.99% performance improvement. Let's look at exactly how much were we able to reduce the payload. So I'm going to jump back into my developer tools. I'm going to stick to my network right here. And what I'm going to do is I am going to update my partial properties. So my patch graph. So I just updated it, and here's my Dash app, or here's my Dash component. and we sent 428 bytes of data that took 34 milliseconds. I'm going to do the same thing. Oops, I'm going to do the same thing with my traditional method. I'm going to clear my network here so that we can see it clearly. I'm going to set the value to 60 seconds. Here's our component, here's our callback, and it's still processing. There we go. So it's sending, as you can see, it's actually sending the entire plotly figure over the network. Sending close to 15 seconds, 16 seconds. There we go, finally. So it sent 68.7 megabytes of data versus just whatever 600 or 300 bytes of data, and it took 16 seconds rather than 32 milliseconds, which our patch class took. And this is the kind of performance improvement that we're talking about. And I'm going to show you exactly the kind of code that we're dealing with right here as well, so you understand. And just as a disclaimer, I was able to make this application in pretty much the same amount of lines of code that I was able to do that in open source, by the way, because I used Dash Design Kit, and it just helped me kind of design it better. But then let's jump into the code. Now, I'm just going to straight up show you my two callbacks, or let's just go into the body. So I have my Dash Design Kit card. This is my traditional method, and you'll see that my other method also has my choropleth mapbox. Here's my data set for that mapbox. I am assigning the location using my GeoID, and here's the properties. Here's the colors in general. What range do we want? What's the color scale? Things of that nature. And then moving on, here's our slider and our opacity. Now, moving on to our traditional one, again, the same body, the same function, just to show you that we're literally dealing with the same graph, the same data, just different ways of managing our callbacks. One with patch, one without patch. Here's our first callback, the one that I used with patch. Notice how small the code is, first of all. What we're doing is we have our output, um, which is our graph and our figure, and our input is our opacity and a value that we pass through that slider. What we've now done is that when opacity is changed, right? So in our callback, when the opacity is changed and the value comes in, all we're doing is we're creating a patch figure under we're creating a patch object, and for the data, within the data, and here's and yeah, so within the data, for the marker, which is the opacity, we're assigning the new opacity value, and we're simply returning the patched figure. Let me repeat that. Okay, let's take a breather. I know it's a lot to take in, but all we're doing is we are simply changing the value of opacity in our choropleth mapbox and then appending that data back into that plotly figure. That's how we're dealing with patch. Now, the traditional way to do that, we had to come in, assign the data, we're passing the opacity, here's our marker, here's where I pass the opacity value, and then I'm building the layout, and then I'm returning the figure. That's the kind of impact patch can have for you. Let's go back to the presentation. So, just some things to keep in mind. One is that when you're using patch, you can only use it with type lists and with type dictionaries. So you need to make sure that when we're talking about the patch function, we're going to be talking about, or there are certain methods that we're going to be focusing on. The first method is prepend. So we have prepend, we have append, we have extend, reverse, and I'm going to add a link to our docs and a link to a couple of blog posts that we have that you're going to have access to after this webinar and even on this presentation. So you'll be able to see the different kinds of functions that or different kinds of methods that we can apply using the patch function or the patch object. Now we have a bunch of different customers, enterprise customers in different industries. So from manufacturing to R&D to healthcare to CRM and you name it. Let's understand some real world use cases because we've understood what this could do, but we also want to understand some real world use cases. And one of the use cases could be, real time monitoring dashboards or a machine status tracking. Let's say if you're in the manufacturing industry and you have, 15 or 20 machines or 100 machines that you want to keep track of, you want to feed real time data into your application. um, Instead of and you have certain KPIs or that allow you to identify outliers. um, what you want to do is that instead of actually having to update the entire application data, you're simply, let's say, creating a button within your application that allows you to update only critical KPIs. You can even automate that process. You can ask your application to update that data every second, but update only the critical KPIs. What that would mean is that um, you're actually improving your app performance, and instead of having to update and wait for so much data to come in back into the system, you're simply just updating that critical KPI within your application. Same applies to a healthcare monitoring system, or it could be a ticketing dashboard, or it could be a BI application where you want to understand the kind of sales, or you want to understand specific KPIs and metrics, or you simply want to update specific values within your application. That's where these real world scenario, that's where patch would apply in the real world use cases. So in summary, we spoke about two main things in our webinar today. The first one being enhancing, how to enhance our application performance, and the second one was how to improve our callback management. The way we achieved that was, in order to enhance our application performance, we actually used and saw real-time application of the patch object. And for improving our callback management, we used duplicate callback outputs that allowed us to write multiple callbacks using the same output. And as a result, we were able to see almost a 99% improvement in performance. But you have to keep in mind, in the real world, when we're dealing with larger amounts of data, depending on the complexity of your data, depending on the complexity of your code, of your use case, these performance measurements can vary. You're going to see performance improvements. You're going to be able to enhance your applications. But think about it this way: if you have terabytes of data and it takes you 50 minutes to update or run an experiment or do something with that data, it's probably going to take 15 minutes or 20 minutes or 25 minutes or 30 minutes. There is going to be some sort of improvement. It's really depending on your use case. We were able to update or successfully enhance our application performance. Okay, and that was my presentation for today. We're now open for questions. And let's see. We have some questions from the team, and give me a second. I'm just going through the questions. Okay, the first question is there a limit to the amount of data partial properties can process? Um, okay, so I think the whole idea, and let me repeat the question, if that wasn't clear. It says, is there a limit to the amount of data that partial properties can process? The whole idea is that there's no limit to the amount of data that partial properties can update or can process. The whole idea behind partial properties is that you have to process lesser or send at least lesser amounts of data over the network. So what it does is it reduces your network payload, and which in result gets you a faster response, which improves your app performance in general. The next question, okay, 1 second. Okay, so one of our viewers asked if there are any specific use cases in which I should not use partial property updates. That's a very good question. So, um, partial property updates work mainly on two data types. One is list, and one is dictionaries. So if you're dealing with any other type of data, partial property updates will not apply to those use cases. And finally, I mean, if you want to update an entire dashboard and not just update a specific KPI, so in use cases where you really need to, excuse me, where you really need to update the entire application or the entire data, partial property updates will not be applicable in that particular scenario. Okay, what's the next question? Is partial properties compatible with all aspects of Dash Enterprise, including the design kit and snapshot? Yes, 100%. Partial properties is fully compatible with Dash Design Kit and our Dash reporting engine. I mean, in fact, I would say it's almost like comparing, say, apples to oranges, because partial property updates is completely separate in general from Dash Enterprise, but it helps. It's definitely compatible, and you can definitely enhance performance of your Dash Enterprise applications using partial property updates. Okay, can the patch work on a data table um, or AG grid? Yes, AG grid. I think AG grid is one of the most popular points of discussions at this time. And yes, partial property updates can definitely work with AG grid, especially when you're dealing with raw data, the raw data property of your AG grid table. Patch definitely can help you improve your performance and perform different functions such as append, prepend, or whatever it is. You can do any sort of data manipulation within your AG grid tables. Okay, and the last question that I have, and don't worry, any additional questions that you have, that you posted in the chat, I'll try and get back to you after the webinar. Um, but one of the I'll take one last question. Okay, let's see. Okay, so it says if I have many callbacks with the exact same output, on which one do I put the duplicate callback equals to true and prevent initial call equals to true? Okay, so that is actually a very, very good question. It's important to understand that when we're dealing with duplicate callback outputs, you only need to add the duplicate callback or allow duplicate is equal to true in only the first callback. And if I can show that to you real quick, let me see if I have that application open. I'm just going to quickly go back to my outputs, to my workspace, and let me just really quickly show that again. So in the two callbacks that I have here, all you have to do is you only have to add it once within your code, only in the first callback. You do not have to add it in the second callback. Just adding this in the first callback is going to make it easier for you to or reuse that output in multiple callbacks. And yeah, and those are all the questions. We're at the top of the presentation time here. Those were all the questions that I could answer right now, but we're definitely going to try and reach out and answer any other questions that you have. My colleagues from Plotly have taken a note of that, and we try to reach back. Thank you so much, everyone. I hope this webinar brought a lot of value, and you're able to improve your Dash app performance using our new updates. Thank you so much. It was a pleasure.